Hey guys, so like I said in class, where we're going next is we have to graph absolute value functions. It's kind of an intro into graphing quadratic functions. Okay, and the two forms, well, it's one form, but with two different types of functions that we're going to focus on today is something called vertex form. So this equation that you're given right here is the entirety of vertex form. Okay, and each one of these letters, A, H, and K, are all going to cause some sort of behavior in our graph. All right. So again, this is what we call vertex form. Now, I've said it many times, but mathematicians here, we're not creative, right? So this is called vertex form because you're in fact given your vertex without having to do any work. You just have to identify certain parts to this form, to this function here, and then they will be your vertex. Okay, your vertex is basically going to be our starting point in the graph. It's going to be the first point that we make, and then we're going to go from there. All right. Our vertex, which is going to be a point, and that point is xy, right? X comma y. It's often thought about when functions are in vertex form, you might also see the letters h and k. Because in this function, this value that's with the x inside of the absolute value bars affects x. The number that would be on the outside, k, affects our y. All right? So when we're given this function that reads y equals -2 times the absolute value of x plus 1 plus 4, we're going to first graph our vertex. We're going to plot the point that's hk. Because we're given a x plus 1, all right, and the form in its entirety is x minus h, it's going to be the zero of what's inside the absolute value bars, which more often than not, students should simply think like, oh, it's the opposite. So our x point of our vertex for this problem is going to be -1. The y coordinate is k, which here is 4. So this is a point, -1, 4, that we're going to graph. We're going to go 1 to the left, and we're going to go up 4 and make a point. All right? So in other words, this function shifted 1 unit left and 4 units up. We went left 1 and up 4. All right, that's our starting point, hk. Where we go next is determined by a, the number or the value that's out in front, that's being multiplied by the absolute value, which is in this case -2. All right, if it helps, put a over 1, because here we're going to go down 2 units, 1, 2, and we're going to go to the right 1 as well as to the left 1. Okay? Absolute value functions, as are parabolas or quadratics, are symmetrical, which means any point that you would make to the right, you can also make to the left of the vertex. Absolute value functions are V-shaped. So these should look like V's. Right? There's no curve to my graph. All right? It should be a V-shaped function that either opens downward or upward. Okay? Why do we think this one opened downward? Well, simply put, because the value for A was negative. All right, and that's it. That's all you have to do. Let's look in the next one, in number 2. Right, you have to identify your vertex, which is H and K. H is always with the X because it affects X. In other words, it shifts us right or left. K affects Y. This is the Y-axis, right? So that means K either moves us up or down. So just like in the last problem, if it helps you, think of the opposite of what we're given here. Right? It would be better to think of the zero of this. What the zero means is if you were to take x minus 3, set it equal to 0 and solve, we would add 3 and we would get, right, x equals 3. So our vertex, our coordinate hk, is 3, 1. So we plot that point. We go 1, 2, 3 to the right and up a unit. All right, that's our starting point. From there, we look at A. A is the number over here that's out in front that's being multiplied by the absolute value, and here it's 1/3. Okay, and again, you could put it over 1 if you would like, which means you're going to go up 1/3, so barely go up at all, and over 1. Do it again, barely go up at all and over 1 the other way. Or if you would like to, and it would work here because think of these, absolute values are V-shaped. So whether I go from the vertex to the right or to the left, it's almost linear, it's constant, which means if I go back to my vertex, I could go up 1 and over 3. That would work. Or up 1 and over 3 this way. Right? However you want to think of it, but you're only required to make 3 points. You're required to make the vertex as well as 2 more points from the vertex using A. Right? Now, this V opens upward. How come? Well, the function's simply positive. Okay. Now we got one more here. This one looks a little different. Where's that number that's in with the x? This just reads -2 times the absolute value of x plus 4. Well, that must be simply that x or h is 0, right? There is no movement left or right on this particular graph. However, there is movement up or down. K is 4, so our vertex is 0, 4. So you can just quick rough sketch 0, 4. Where do we go next? Well, we have to go down 2, -2, and over 1. And because these are symmetrical, we're going to go down 2 and to the right. We're going to go down 2 and to the left. There's our 3 points, which is all I'm requiring for now. And we make a V. Right, and that's it. Now, similar to absolute value functions are quadratic functions, but when they're given in vertex form. So you'll notice that in its entirety, almost like in its formula, if you will, right? It looks the same as the absolute value. What's different is simply parentheses instead of bars. I noticed here that I forgot to put the squared on all of these. So for it to be a quadratic, our x has to be squared. In this case, it's x minus h squared or x minus 2 quantity squared. But we're going to go about graphing these the exact same way as we did the previous 3 problems. We're going to identify the vertex, which is opposite of what we see here, or the 0 of it. So 2, 1. We graph 2, 1, over to the right 2 and up 1. We look at A, and we're going to go up 3, 1 to the right, go back to the vertex, up 3, 1 to the left. These are not V-shaped. Quadratics are parabolas. They're U-shaped functions. All right, they should be a little curved to it. So they're not V's, they're just curved. They're U-shaped. And the second one, all right, what do we know about this? Well, we know it's a quadratic function because we have the x squared. We know that it's going to open downward because the function's negative. I'm going to start at hk, which is -1, 3. So I go left 1, and I go up 3. Make a point. Take another look at A, the value out in front. That's how many you're going to go down. 1, 2, 3, 4, and 1 to your right, and 1 to your left, because these are symmetrical. All right. Now, it doesn't look the best here on the video, but again, you're going to make a U shape once you're done. All right. And the last problem here. If you want to pause it and try it on your own, go ahead. If you just want to continue taking notes, same thing. So notice here, something's missing, right? Where's that plus k? Well, in this case, k just must be 0, and there's no sense of me writing plus 0, so that's why you didn't see it there, right? You just saw y equals 1/2 times x minus 5, and it should have been squared. All right, so what do we do? Well, where are we starting? We're starting at 5, right? The opposite of what's in the parentheses, and then whatever k is. So 5, 0. All right, we're starting on the x-axis. And then you have to remember this. because these are U-shaped, they're not constant. They're not like in a linear form in any way, which simply means you cannot go up 1 and over 2 here. Absolute value, you could get away with that, not with quadratics. All right, we have to put it a over 1, which means we're going to go up a half. So we go up only a half unit, excuse me, and over 1. Up a half unit and over 1 the other way. And then you make your U. All right, guys, that's it. All right, that's us graphing quadratics. So next time I see you, I would expect you to watch this video, take some notes, and we will go from there. We'll start doing some practice problems together in class, and also come prepared with any questions you might have. All right, thanks, guys. Enjoy the rest of the day, and I'll talk to you soon.